Welcome back to another episode of Carterra's Scientist to Scientist series. My name is Alyssa Hughes. I'm an application scientist with Carterra, and today on the show, I'd like to welcome guest scientist Mike Brown. Mike is a senior scientist at Adimab, and he'll be answering questions today on high-throughput binding characterization assays and antibody discovery. Mike, welcome.
Thanks for having me, Alyssa.
Yeah, absolutely. So let's get started. Kind of diving in, could you explain a little bit about what you guys do and the focuses that you have in the applications that you're running?
Sure. Yeah. So this slide characterizes it fairly well. No pun intended. We're a protein analytics group at Adimab, and we've got about a little under 20 people who are split into three groups. We have an antigen quality control team. We have a mass spectrometry team, and those folks are really charged with quality control on our antigens, on our outputs from our selections, antibodies, antibody fragments. And then there's a sprinkling in of this developability characterization that has been big for the last 10 years or so. The mass spectrometrists work on chemical liability assessments, and then we all sort of pitch in on some of these developability characterizations like the thermal stability, the hydrophobic interaction chromatography, the AC-SINS assays. And then the group that I'm primarily associated with is the group that does most of the kinetics and affinity measurements and epitope binning. And so that's the primary focus of my team and my group, and probably why you're talking to me today. And so, the application, at least on the Carterra side of things with the LSA that we use the most is the kinetics application. But we also do a fair amount of epitope binning as well. So we use, both applications there.
Yeah, that totally makes sense. So with similar applications and comparable data, what advantage do you see in using the LSA over other instruments in your workflow?
Yeah, so there are a bunch of advantages to using the LSA. And when I think about it as we're doing more with less. And I think your website does a great job of letting people know that you can run a lot of samples with very little antigen, especially on the kinetic side of things. So with the epitope binning, you do consume a little more antigen than on the kinetic side of things. But that also translates to savings on the other consumable side of things, the sensor chips, the sensor tips, that sort of thing. And so we see a lot of cost savings from putting things over onto the Carterra. The other of the more with less is that just running the experiments themselves are quite less labor intensive than some of our other platforms. And so you kind of have that set it and forget it type of experiment where in some cases, for a 96 by 96 epitope binning experiment, that experiment goes on for 3 days in some cases. And so a person can go on vacation. And so that's how set it and forget it the Carterra LSA can be at the extreme. And then the other thing is on the more side of things, it's by far our highest throughput instrument in the lab, and so we're able to collect more interactions per cycle. This 384 interactions in a single cycle is something it would take 4 instruments from one of our other platforms to do this, collect the same amount of data in the same similar amount of time. And so those are some of the main advantages I think that we get from moving things over to the LSA.
Yeah, that's fantastic. It sounds like with that high throughput and the set it and forget it, like you guys have weekends and that's an incredible amount of work that you guys are able to kind of push through really quickly.
Yeah, we're doing like 10, 15,000 interactions a month on the kinetic side of things.
Oh, wow.
And we're doing a couple of epitope binning experiments. Sometimes they're 96 by 96, a month. And so, yeah, huge. We're cranking out a lot of data.
Yeah, absolutely. So, how does having the LSA in your characterization strategy kind of change the process upstream and downstream, the way you guys work?
Sure. Yeah, this slide addresses it quite well. So, one of the main advantages and on the upstream side of things is to be able to benchmark our samples much earlier in the process. And so here's an example. I show on the left hand side this idea that the Biacore and the Carterra can give you basically the same kinetic parameters. And so for us, when we do collect Carterra data, we trust the data, and it allows us to, in the case of the sample shown here, where we've got a benchmark control that's in the 200 picomolar range, and we see that from whatever output we're now we're only at 17 nanomolar in terms of affinity, and we want to get to that benchmark. We know, and we can communicate that to our partner that we're not there yet, but we know in a cycle or two we'll be there, and we'll have antibodies for you. So on the communication side of things, it's great, because it's key to, at least to our business, to be able to communicate results, intentions, as early as possible, so everybody, all other plans can be put in place for these samples later on. And then just on the again, on that upstream side of things, the ability to be able to test as many samples as we want, and test as many antigens as we want, and not really compromise at all on that side of things, is something new, at least using the Carterra LSA. A lot of times with our older platform and other platforms, we often have to make decisions based on maybe screening a single antigen. And then we have to cull samples from that. And then we're regridding samples in order to then test against some of these other reagents. And so in the case of using the Carterra LSA, we're able to just screen them all. And so, again, set it, run it, go on vacation, whatever. We're big on vacation at Adimab, and so so that is key, at least for us, the ability to just collect as much data as possible, and then also because we can make better decisions that way. And then the epitope. Being able to provide a detailed epitope binning profile is more of a downstream thing. The more detail we have for a particular clone, the more information we have about how specific it binds, can help us make the best decision for us and for our partner.
Okay. Yeah, absolutely. That sounds like it's very useful for you guys, and you make good use of your time. Absolutely. So could you tell us a little bit more, in your talk at our recent symposia, you talked a little bit about your FC formatted antigens and how you're using those to improve quantitation of weak binders. Can you talk to that a little bit?
Sure. Yeah. So for years we've run this assay on our other platforms, and the idea is that a lot of times for whatever reason, and I shouldn't say a lot of times, sometimes we have projects where the output, we get weak binders initially. We're starting from sort of a naive state, and it takes sometimes a couple of rounds to get high affinity clones that bind to the antigen, and so for us, using this AVID format of the antigen allows us to pick out weak binders and out of the grass. And so here's this assay format is it's pretty straightforward. We are doing a capture kinetics assay on the Carterra. We'll immobilize the GOAT anti-human FC IgG on the sensor surface. And the idea is to capture the IgG of interest, and then block with an irrelevant IgG. And that should block all sites on the sensor surface, such that when you do come in with that FC fused antigen, even if it has the same FC, there shouldn't be any interaction with it on the sensor surface. And you can see down in the bottom left-hand corner, the Addy IgG1, you see no binding, and that's a good indication that there's no binding of the FC of the antigen to the sensor surface, and that way you can trust the rest of the data and the rest of your output. And here we're able to rapidly be able to tell whether or not one clone is better than another. We're not really worried about the intrinsic binding affinity in these experiments. We're really just relatively ranking things. And you can clearly see in this case, like Addy IgG2 is a better binder than Addy IgG3, and so we can communicate that to the partner, and they can make decisions going forward.
Yeah, that's amazing. I feel like being able to communicate those things early and like very directly is very helpful for sure. So could you share a little bit more about your experience in identifying more bins on the LSA versus other platforms, and why is that a benefit to your workflow? Why is that helpful for you guys?
Yeah, so the thing that gets people most excited about the Carterra and the LSA and the instrument itself are these heat maps. Partners get excited about them. Our campaign managers get excited because they just provide such a rich amount of detail on the binding properties of our candidates, and so I think it's probably the clear benefit is just having that much more detail. Some of the other experiments that we use, we don't get that fine of detail. We're not looking at both assay orientations, and so being able to do things in both orientations, with each the IgEG both on the sensor and both in solution, we will very rapidly be able to get to a point where we can find new bins and be able to really provide those finer details to our partners. And sometimes these fine details can turn out to be so unique that maybe there's the opportunity to file for some intellectual property, that sort of thing. And so the more information we have, the better decisions we can make. And these heat maps often provide really enlighten us on what our output is providing us.
Yeah, absolutely. Well, Mike, the world of binding characterization assays for antibody discovery is so exciting, and there's so much going on in the space. I really appreciate you speaking at a recent symposia. It was really engaging and very beneficial in me kind of getting up to speed in SPR. And thank you so much for joining us again today, helping us produce this video and sharing your Carterra story. We're excited to have you as one of our users.
Thanks. Yeah, this was super fun. Thanks for having me.
Absolutely.